So Livermore is the other weapons design lab. We heard about Los Alamos. We do a lot of similar things. Again, the focus is weapons design, and with that comes a lot of other capabilities. We have a pretty big laser facility, of course, and some high performance computing is another aspect of Livermore that can be used in verification technology also. We do a lot of work for DNN, both in what we call NA-22, but also NA-24, the Non-Proliferation and Arms Control Organization. And there's a good synergy, and I think it's interesting in the point of contacts you see from the National Lab. Some are people focused on the R&D side, others on the Non-Proliferation and Arms Control side. So I think there's a lot of good overlap with this consortium and those two organizations. One focus we've had at Livermore has to do with counterterrorism, nuclear counterterrorism, and a lot of equipment was developed for that, as it was at a lot of the national labs. And one thing we're trying is to see how well you can use that kind of equipment for treaty verification, because it's not a perfect match, but it's close. A lot of similar concepts come into play. And we've been working with our colleagues in the UK on some of these demonstrations, and I think they've gone fairly well. What I'd like to talk more about today are some opportunities that we have in the consortium in certain areas. One big one is radiation detection. I think this is the signature for a lot of the national labs. But a couple of groups I wanted to point out, one by Steve Payne, where they really are looking now at some new materials, but putting them into actual devices that work. And so here are three different projects that I think could really benefit from some participation from CBT fellows or interns, both in terms of strontium iodide detectors. They've come a long way on this scintillator, works quite well. We do a lot of work with these ceramics, and there's a very large array of these garnet gamma detectors, and time now to start putting these into systems. There's a lot of work to be done on that. And that same group also has lots of projects involving semiconductor gamma detector device development. There's just lots of details and lots of good work to be done there. We've heard throughout the last couple of days about these various neutron detectors, these plastics. Natalia Zaitseva, her group is still very active, and she's interested in having students work with her in developing new scintillators. Again, boron-loaded plastic scintillators, which we've already heard about today, and these large-scale solid-state organic scintillators. Also, we've seen those. We've seen data from those today and yesterday. The other area that I have lots of opportunities is with Bill Walter's group in geophysical monitoring for underground nuclear explosions. This group is doing a lot of work with NA-22, and recently, well, last year at the beginning of the fiscal year, they were involved in a very large exercise with the CTBTO, the Comprehensive Test Ban Treaty Organization. They did this huge exercise, integrated field exercise in Jordan. Several of the NSA labs participated, especially LAML and PNNL and Livermore, and colleagues from the UK participated in that. It was a big success that was held in Jordan last year. But this group is very active in that, but they're looking for students, both in developing new algorithms and looking at big data. We'll have a student from the consortium join us to look at big data next month. And there's lots of other interesting things from Bill Walter. Finally, I wanted to mention that these measurements at DAF are very interesting to Vladimir Mosin, one of our new scientists. They're developing equipment for a chain of custody project in NA-22. They've done some tests at DAF. They think they've got equipment that is quite suitable for work by students, by graduate students, and learning how to handle the data from these detectors. So they're very interested in that, and I think it's kind of important that we have places like these experiments at DAF and this place at Y12 where I've done some measurements that Carter described. It really is important to measure large objects in this game. You can do just only so much in the laboratory. I know in my experience, we've had very highly successful uranium enrichment measurement systems developed in the laboratory. But when you take them out in the field and you have to measure kilogram quantities, a lot of things change, a lot of things become important that you may have missed. I know John Valentine and I both had experiences measuring these things in Russia, where it's really important to have a more realistic sample size. So once you get the fundamentals worked out in the lab, you really need to run them by some large pieces of material that apparently now is available both at Y12 and at DAF. So I really think this is an important thing, and it's really quite an achievement. So if you have any questions about other opportunities in Livermore, please give me a call, and I thank you for your attention.
We did not have decent testing facilities to do this. I was founder of one of the nuclear instrumentation companies. We had no place to really test our own